Hey y'all. Yes, you will, Madison. You will need paper. Um, so hey, I don't know how many people are in here right now because I am trying to see three. Okay. Um, this is going to be kind of fluid since this is honestly my first time trying to do this as well. But I hope everyone is doing it well. I miss you all a bunch, and I can't wait to everything to settle down and for us to get back to school. I'm not sure how long we're going to be out since this is such a fluid situation. But we can review right now. It is playing back through here. There we go. But we can at least go through some review, and we can take this opportunity to focus on learning something new, whether it be a skill or hobby, and to strengthen the knowledge we already have. None of these are required, just as a heads up. Um, and anything I give y'all in here, I'm not grading, so you don't have to stress about any of that. Um, Paper and pencil would be good so you can work out the problems as we're working through them. And I know some of the classmates do not have internet, so if you could pass this information on to them any way possible, whether you're going to text them and go over the information, you can call them, because if you can explain it to them in your own words, not only does that help them out, but it also shows that you know it as well. Um, and I am going to start with algebra topics first, probably for the next half hour, and then pre-algebra. So if you're here for the pre-algebra review, come back in like a half hour or so. Um, because if we go in longer, then I can let you know it's gonna be a little bit longer. I just set the hour just for today, just to see how this would go, since it's my first time using this. Um, and then all the videos are going to be up there as well. And I have it right now where hopefully the chat box is going to be showing in the video, so you can at least go back through it and see what people are asking questions if you weren't here live. Okay, so let me get this up. I was going to go through oh, I'm on the wrong one. There we go. Okay. I was going to go through law of exponents because that seems to be what everybody is having problems with for algebra. So let's go through some of that stuff. Alright, so remember with a law of exponents we have a couple of different things. The first thing we learned was that anything to the 0 power is 1. And then after that, we learned that anything to a negative exponent is going to be as a fraction. Ooh, that was an awful 2. And vice versa. So if we had something like 1 over or x to the negative 3, then we would flip that. So it'd be just x to the third. And then after that, we learned about if you're multiplying things of the same base. This is not working. Hold on one second, y'all. If you're multiplying, they have the same base, then you can add them. So we would have this as 2 plus negative 3. So 2 plus negative 3 is going to be x to the negative 1. And x to the negative 1 would then be just 1 over x. And then the fourth thing we learned was the raising a power to a power. So if we have x squared, and then we have the parentheses out here, raised to the third. So that's like saying x squared times x squared times x squared. So if you add those all up because of the law of exponents we just talked about, that'd be 2 plus 2 plus 2. So that'd be x to the 6. And that's why instead of writing this all expanded out, we just multiply. So 2 times 3 would just be x to the 6. So that's why we get this answer right here. And let me switch this real quick because I'm going to have it where you can actually see my mouse. That's going to go out for a second and then it should come back. Okay. So, yes, now you can see it. So that's why then we have now to the 6 over here. Alright, so then the last thing we went over was the division rule. So if you have something like x to the 3rd over x to the 2nd, that is like saying x times x over x times x. And if you divide these, just like 2 divided by 2 would be 1, it's the same thing as x divided by x would just be 1, so that cancels. X divided by x would just be 1, so that cancels, so we're left with just x. And instead of, again, just writing all these steps out, the easiest thing we can do is just subtract them when you're dividing. Alright, I'm going to erase this, and now we're going to actually start working out with some problems. So, clear the canvas. Alright, and the problem we're going to use, let's start off a little easy first. We'll use so 2v squared, that's in parentheses, so 2v raised to the 2nd power times 2v squared. Alright, so out of the few of y'all that are in here, what do you think we should do first? This is much more. So this is going to be a little bit of a time lapse, y'all. So if you see where it's like really slow for a second, it's because the way that the stream service is going through, my encoder's taking a little bit longer than when I was using my other one yesterday. So I may have to switch back to that encoder for tomorrow. So at this point, I'm just going to keep going, multiply the v into, good. Okay, so, Madison, you're right. So the mistake that I kept seeing, though, on the test was that students would multiply 2 times 2. Now, granted, this was still going to come out to the same answer, but they would multiply, and that's not the same case. You're going to raise that value, so it's going to be 2 squared because you're multiplying the exponents. So right now we're going to pretend like there's an imaginary 1 right here. So 2 times 1 is 2, and we're going to do the same thing to the v. That's v to the 1st power, so 2 times 1 is 2. So then that makes that v squared. Oh, come on now. There we go. V squared times 2v squared. At this point, there's 2 things you can do here. You can, using the law of exponents, since 2 and 2 are the same base, you can go ahead and add your exponents, because again, there's an imaginary 1 right here. Or you could simplify, so this would be 4, and then you could multiply by 2. So at this point, I'm going to just draw that over here if you'd rather do it this way. So the first way is you can add your bases if they're the same base, so 2 and 2, so 2 plus 1 is 3. Or you can rewrite it as 4v squared times 2v squared. And then you could do 2 times 4, which is going to give you 8. Which, if we did 2 to the third, that's still, oh, as well, 8. Now, the only thing I haven't done is now dealt with my variables, and this case is going to be the same thing. So v squared times v squared, since they're the same base again, v and v, we can just add our exponents, so that's v to the fourth. And so this would be our final answer, and in the case of using it this way on the right, it'd be the same thing. So v squared times v squared is going to give you the v to the fourth, so you still get the same answer. You can see this as being a little bit quicker, but it's about the same. Okay, so I am going to clear that. And let's try one that's a little bit more difficult. Let's use this one. Let's write in red. So this one's going to be a little bit of a lengthy problem. So we got 2x squared, that's a terrible y, to the fourth times 4x squared y to the fourth times 3x all over 3x to the negative third y squared. Alright, so for something like this, your the fraction bar is going to be just like a grouping symbol, which we went over way back at the beginning of the year. But you're going to want to simplify the top first, and then we can come down and start dealing with the subtraction portion of the law of exponents. So you have 2, 4, and 3 for your coefficients, so I'm going to combine those. So 2 times 4 is going to be 8, and then 8 times 3 is going to be 24. So 24 is going to be our first coefficient, and there's nothing that we have to multiply on the bottom, so I'm just go ahead and write 3. Then on the top, we've got x squared, x. So again, all the same bases, x, and x. So we're going to just add the exponents, so 2 plus 2, 4, plus the exponent of this x, which is 1. So that's going to be then x to the fifth. And then we're going to do the same thing with our y's. So we got y to the fourth, y to the fourth. So we're going to multiply y to the fourth times y to the fourth, and we'll get y to the eighth. Give me a second to catch up because it's still a little bit slower. And then on the bottom, we didn't have to combine anything, so I'm just going to write the x to the negative 3 on the bottom and y to the second. So at this point, you can subtract, and I would just subtract our exponents, and then for here, you would just do 24 divided by 3, which, lucky enough, we already know 3 is a factor in there, so we're just going to cancel those out. You could have even canceled those out at the beginning if you wanted to. There's a variety of different ways, and in fact, you know what, I'm going to go ahead and move this over, and we'll do it just a slightly different way. So if you wanted to instead, you could cancel out the 3 here, since you know 3 divided by 3 is 1. And you could also rewrite this so they're all in the same line. So if you wanted to, another way to do this is to write everything on the same line. So you could write this as 2x squared y to the fourth times 4x squared y to the fourth times 3x times, now this would be the tricky part if you wanted to write it all in one line though, is this 3, since it's in the denominator, if you want to write it where it's all in the same line, so it's as if it was in the numerator, you would have to give this an exponent, and that exponent is going to be a negative 1 because we're going from the bottom to the top. So this would be 3 to the -1, and then with our other ones, we would just do the inverse. So if this is a -3 on the bottom, it's going to be a positive on the top, and if it's a positive on the bottom, it'll be a negative on the top. So let me just move this over just a little bit more. So then that'd be times x to the third and y to the -2nd. And then you would just combine like you would do. So anything that had the same base, well, this has a 3 and this has a 3. And the exponent of this one's 1 and 1, so that's how we can cancel out right off the bat for that and then continue on. So this answer is going to be the exact as this, and we're going to work this one out real quick. So I'm going to stop talking for a second, then we're going to come back and rework the red one just to show you that they're either way works. Two plus 2 plus the 1 right here. Give this imaginary 1. 2, 2, 5 plus the extra 3 is going to be 8. Y to the fourth, y to the fourth, y to the -2nd, so 4 and 4 is 8, minus 2 is going to give us 6. So if we did this right, the red one should come out to the same as well. So let's see. 24 divided by 3 is going to be 8. 5 minus -3, so 5 minus -3 is going to be x to the 8, because that double negative makes it a positive 3, so that's x to the 8th. And 8 minus 2 is going to be y to the 6th. So we actually ended up getting the same answer, which should have been. Let me scroll out so you can see that. Okay, so you could have done it that way. There's a bunch of different ways we could have solved this. For those here, I'm going to wait a second too. Is there any other ones you want to go over like this? I know scientific notation was the next one I wanted to go over. But I just wanted to see what y'all, if you want to have another problem that it's just the product and, I'm sorry, the product, raising the power, and the division rule, or do you want to go into scientific notation now? Alright, so if nobody has any complaints, then I'm going to go ahead, I'm going to do a scientific notation. Oh, Maria, scientific notation it is. I would probably put a lot of people asleep if I did audio. Well, I guess that's the point of some audiobooks, though, I guess. Alright, scientific notation. Debating on, I don't think y'all need to know how to, well, okay. So, just to review on scientific notation, just in case, I'm going to do that really quickly. So, in fact, I'm going to throw a 0. So, 306,000 and 0.00000602. These are going to be two different ways that we have to do it. So you have a really big number, and then you have a really tiny number. So if it's large, we're going to condense this, and when we condense this, you want to put it right behind the first decimal point. I'm sorry, the first digit. When I say digit, so this is all the way in the 100,000 spot. But you're going to put it behind the 3, because we're trying to make it smaller. So 3.06 times 10 to the, and now we need this exponent. Now the thing about the exponent is that we're having to tell how many times do we have to multiply 10 how many 10s do we have to multiply to get this number back to where it was? So right now, I took away 1, 2, 3, 4, 5. We would have to multiply 10 5 times in order to get back to 306,000. And then when we're going for a decimal, you have to do, so again, you're going to put it behind the first digit you see, so we're going to put it behind the 6. So that's going to be 6. Oh, what is going on? 6.02. And this time we have to tell how many times do we have to divide by 10. Okay, and that's when we're using the negative exponent, because then it's going to be underneath. So this is going to be 1 over 10. How many of those do we have to multiply by? So that's 1, 2, 3, 4, 5. So these would be how you would set that up if you just needed to write it simply in scientific notation. Now we can use the law of exponents at this point though, because if we wanted to multiply them, we can multiply them. If we want to divide them, we can divide them. So I'm actually going to use these exact two numbers, and I'm going to multiply them, and then I'm going to show a problem where you're going to divide them. So blue, we're going to multiply. Let's write multiply right here, so in case people are watching. Multiply. And if you divide that, oh no. And we're going to do a division problem here. Oh my. Writing is all sorts of wonky. So let's do the multiplying first. So I'm going to multiply this number and this number, so I'm going to rewrite that. 3.06 times 10 to the 5th. Oh, this is going to come out easy. So, I'm going to change this number. So that's the number we'll use to multiply by. We'll at least use that number. Except I'm going to change my exponent for this one, because I want this to be a little challenging. 6.02 times 10 to the... Let's use... I still want a negative, so let's do negative 7th. Alright, so what are you going to do? You are going to multiply your first factors. So 3.06 times 6.02. Oh, you know what, y'all? I don't even have a calculator right now. Calculator. So 3.06 times 6.02. And if you want, let me do that actually real quick. Let me pull up Desmos, since I will probably need to use that in the next one. Desmos. So just real quick, 3.06 times 6.02, you get 18 point, honestly, I'm going to go ahead and cut this off at the 100th spot, so the second decimal place. So 18.42 is where we'll stop, just to make this a little bit easier. Desmos calculator is going to go away in just 1 second, so 18.42. And now you can do your base 10, since they both have the same base, they both have 10. What can you do with the exponents? You can add the exponents. So 4 and negative 7 added together, 5 and negative 7 added together is going to give you times 10 to the negative second. So that's going to be times 10. Okay. Oh my goodness, y'all. Sorry, I don't know what I'm doing right now. Okay, so are we done? This is the point that a lot of people have some difficulty with. Is because this is not in scientific notation. One way to do this is that you have to move this one away. You have to move it one up. So you would be adding a 10. You'd be adding a base 10 or multiplying by a base 10 to get to there. The way that I think helps some is to take this factor. So what I'm going to do is I'm going to draw a circle around. What is this color? I have no idea what this color is. Let's see what this does. Oh, I do not like this at all. We're going to use it. So, I'm going to rewrite this over here. Let's not even pay attention to the division rule right now. So I don't want you to focus don't even look at times 10 to the negative 2 right now. I want you to just to focus on the 18.42. That's not in scientific notation. If I wanted 18.42 in scientific notation, ignoring all this, in fact, let's get that off the screen so you're not even looking at that. How would I write this in scientific notation? So to do that, I would need to take this decimal and move it one spot to the left. So it would then be underneath 10. So that would be 1.842 times 10 to the 1, because we only moved it one spot over, so by a factor of 10. Okay? Now that we have this in scientific notation, I'm going to replace 18.42 over here with this, because they're the same. They're the exact same, except one's written correctly in scientific notation, the other's not. So with doing that, I'm going to get this wonderfully unicorn color away, and we're going to rewrite that as 1.842 times 10 to the 1. That was what was replaced. And then write what was left that we didn't change. That's times 10 to the negative 2. What happened to the negative 2? Okay, so right now the negative 2 is still there. I'm not paying attention to that at all. It's still here. We're just rewriting what the 18.42 is. It still has to be part of it. It's still part of that situation. But it's it's going to take into place right now. So we got 10 to the first. Yeah, I can tell. It's because my encoder is taking a lot longer to do something. So what it is going to be times 10 to the negative 1. Tomorrow, though, y'all, I'm going to use a different encoder. So right now, I thought this would be better because it allows me to do more, like, switch between stuff a lot easier. But I will set up the other one tonight, and so it won't be as laggy, because the one yesterday was, like, on point with me being able to see everything, and I have no idea. But, yeah. But so, Madison, you are correct. This is going to be, get this back here, 1.842. You still have the base 10. 10, 10, 1 plus negative 2. So that's then times 10 to the negative 1. So that would be your final answer at this point. So I'm going to do a division problem real quick, and then we'll cut it for algebra. Unless y'all want to stick around just for a little bit, because if there's nobody from pre-algebra, or they show up later, then I can start that later, and I can do another problem. But I can't see like who is here and who's not. I can only see who's viewing the stream. Or, I mean, how many people are viewing the stream. So if you are somebody here waiting for pre-algebra, can you let me know? Because then that way I know to stop after this problem. The other thing I'd like to know is for y'all, because actually I can watch it later, but I just didn't know if the comments are going to come up. I know they can pop up on the screen for me when I'm recording this, but if they don't pop up, like because the other one will not let me have the, let's do 3.06. It won't let me have like the comment stream coming up. So if I can't have that with the other one, it's gonna be you're gonna be a little lost if you all ask questions. Let's do the same number, 6.02. This is gonna come out pretty easy too. Okay. So first factor, divide. So 3.06. So what I'm going to do instead is, if we're going to divide it, so you can do one of two things. You can divide it, and you can get the decimal. So you can do it that way first. Or, actually no, let's just go ahead and do it that way. So let's do 0.51. We'll just make it easy. We're again to the nearest hundredth. So 0.51 is what I'm going to write. So I divided these and I get 0.51. So that's when you divide these two. Then again, base 10, 10, 10. So 5 and the negative 7 we're going to subtract. So with doing that, you'll get 5 minus -7. So 5 minus -7 is then going to be times 10 to the, so that's like saying plus 7. So 5 plus 7 is going to be 12. But we're not done. We're not done. So how do we finish this up? We're going to turn this into scientific notation again. So I'm going to grab this god-awful color and circle that. Oh my gosh. And then we're going to go right over here. So 0.51 is not in scientific notation. So I need to move this back. So that's going to be 5.1 times 10 to the -1. So now I'm going to take this. These are the same, so I'm going to replace them. So 5.1 times 10 to the -1 times 10 to the 12th. Base 10, base 10. So -1 plus 12. So 5.1 times 10 to the 11th. Now, if you, I'm sorry, it's not that bad. It's just, it's very bright for me. If that, because I know some of y'all are just going to do, oh, it's just, I got to move it one space over, so I'm going to take it away. If I move it one space forward, I'm going to add to it. So either of those ways works. I know some of the students were doing it that way, and that's how I showed it originally. This is just another way that I think will help with, like, oh, do I need to add? Do I need to subtract? That way you can see exactly what you're doing. So that's one way that you can do that. Okay. I haven't seen anybody say anything about pre-algebra, so I'm gonna do one more problem, and then I'll do that. Do y'all want another scientific notation one, or do you want another, do you want me to go, because radicals is what I had next on the list. Radicals, all right. For radicals, oh, direct and inverse. Okay, all right, I'll take a vote. Y'all, also, family game night. I don't know. But for we could do, yeah, let's do, since you both want to do direct and inverse, we can do one of those problems first. Do you so I had on my list for direct and inverse, there were a couple of different things. There was there was finding it whether it was from a chart, and the other one was if it was like a word problem I was going to go through. So I didn't know if the word problems were the ones that was giving you all the tough time, or if it's the, how do I know if they give me a table that it's direct and inverse. I can do both. I just didn't know which one you'd rather me work on for right now. And how, what is this? What is this one? Oh, dang. Okay, I'm assuming we're gonna go with word problems first, since we're still talking about game night. Alright, so, oh, TikTok would be a good idea. I did not think of that either. Alright, I'll look into that too. Because I know some of y'all aren't, like, they don't have the data to download the long videos either. Okay, so I'm gonna do a word problem. Let's say, oh, so just to go back over though with direct and inverse, The thing that was getting a lot of students is not remembering that it's y. Oh my gosh. I think the darker one's gonna be what? Yeah. Y varies. I can't. Nope. Can't do it. Y varies either directly or inversely with x. So whatever comes in words first, that is your output. Um, so if I was to give you a situation like money, that's probably the easiest one, isn't it? So money varies directly with time, and that makes sense too, especially um, if you work in a wage job, so an hourly position. The more that you work at that job, the more money you get. So if you're getting $8 an hour, then every hour that you work, you're getting $8. So if you work there 1 hour, it's 8. If you work there 2 hours, it's 16, 24, 30, 32, and so on and so on. So your money is going to keep increasing over time. So if money varies directly with time, let's say if uh, Stan, lowercase s, Stan, works, let's say 40 hours in the week, 40 hours in the week. He gets paid. Come up with a number. Let's do $640. Gets paid $640. Um, so one, what is the equation for that? So what's the equation to show that relationship or that variation? So what's the equation? Two, how much, and we're gonna go over the formulas in a second, just give me 1 second. How much does he make in 52 hours? Alright, so the first thing is the equation, which Madison also brought up, so remembering the formulas. So remembering the formulas, the formulas for direct and the formulas for inverse. So direct. So that's that linear relationship. So as time goes on, or as something goes on, as your input continues to increase, what happens to your output? It continues to increase. So it's a linear relationship, and that's shown in the form y equals kx. And that kind of reminds us back to like when we were dealing with slope-intercept. Like k is our slope, and x is still our input. So as this goes up, so does your y. Now the opposite to that is inverse, and an inverse graph is different. It's an exponential graph, so it goes down. Wow, that is very awful. It also actually is in two quadrants. It's in both either the first and third quadrant or the second and fourth, depending on what the value of k is. And this line never officially touches the axis or the axes, because it never touches the y-axis and it never touches the x-axis. And the reason for that, you can actually look in the equation. So that's y equals kx. If I put a 0 in for x, what happens? So if you put a 0 in for x, it becomes undefined. That's non-existent. So you could never actually have a y-intercept, and if you were to flip this, so if I brought the x over, so that's, if you were solving for k, you actually get xy equals k, and if I wanted to then solve for x, so I would divide by y, if you put y 0, you could also never get an answer for k, so you can't even get an x-intercept as well. So that's why you have these what are called asymptotes. So where you can never touch. It gets progressively closer and closer and closer, but never officially crosses that line. So these are the two equations. If you want it in terms of k, you have xy equals k. And if you were to solve for k for direct variation, you would get y over x equals k. Because remember, back from literal equations, you had to solve by, so we would divide, we do the inverse. Since they're multiplying, we do the inverse, and you get y over x equals k. So remember, either these or these. Either are fine, because no matter what, you can solve it in terms of y, because y'all know how to do literal equations. Or you can remember it this way. Either way, you'll still get the same answer. And even if you, let's say you completely blank out on literal equations, period, at least if you remember these, you can solve using one-step equations, because you'll either have to divide or multiply. Since we're dealing with direct, we're going to use this column right here. So for the equation, what do we know? So what is our x value? What is my highlight color? Can I pick my highlight? Oh, yes. So let's use red. So remember, y, oh, that is not going to work. Y comes first, so in terms of words though, don't worry about the numbers. Pay attention to what they say. So money is our y. So once you've highlighted that, once you've defined that, so money is our y. So then go and let's write down the number then. The money that they gave us was 640. So I'm going to go ahead, I'm going to highlight that too. Right? And then our x came second, and that, so x varies directly with time being our x. So 40 hours is our time. So writing that down, we have time is our x, so that's 40 hours. Well, if you blank out, use the dump sheet. Y'all can write that quickly down before you get started. So if you have to if you have to cram one thing before a test or an SOL, at least write those down. So we got that labeled out. Now that we have that, now we have to think about our directly. So I'm gonna, oh, I can even change those colors. I will change those. Highlight. Let's see, I already used red, you used green, let's use orange. So directly, and because we're doing directly, so direct variation, y equals kx. So what do I know? I know my y, and I know my x. What do I not know is my k. So plug it in, just like an air freshener. So let's plug the 640 in for y. So 640 equals, we don't know k. We don't know that yet. We're going to find that. We know our x is 40 for right now. And what do? We need to solve for k, so we're going to divide by 40. $640 divided by 40, or 640. I know nothing currently. It's all up in the air, so I'm giving y'all as much as I can right now, so let's just pay attention to that for right now. 640 divided by 40 gives us 16. 16 equals k. Because you want to learn, that's why you're here. Come on now. Equals k. So are we done? Nope. Because this is just the value of k. The thing that you need to rewrite now is the equation. You could see it as y equals 16x, or in terms of where you had it in terms of k, so you could have it as y over x equals 16. So either of those answers could be there. Okay, so we're not done. That was the first step. The second thing we're going to do is then how much does he make in 52 hours? So now that we have our equation, I'm going to use the first one that we wrote. So y equals 16x. I'm going to use this. So this was 1. Oof, that is awful. That's 1. So this is going to be 2 right here. So how much do you make in 52 hours? In 52 hours, hours is our x, time. So we're going to put that in for x. So y equals 16 equals 52. So 16 times 52 is, calculator, 832. So he gets $832 would be your answer. So that's both. If that was a two-part question. So that's something you may see. This is not required. I said that over and over again. None of this is required. I am not grading anything. I'm doing this out of the kindness of my own heart to give y'all some opportunity to still go review some stuff, if you'd like. So that is what I'm going to stop there for algebra. I'm going to do a few problems for pre-algebra. And then tomorrow probably do the same time, and I can extend, like I said, I can extend it. We did this for 45 minutes, so I can do that again tomorrow. If there's more stuff y'all want to go over, if there's any science, I can help with some of the science, especially the physics, and some of the biology. I do love y'all. I miss y'all a bunch. But we'll stop here for algebra, and then you can stick around for pre-algebra if you want to review that stuff, because I'm going to go over slope today, and then which is something y'all have to know as well. But if you're good with that, then you're good, and if not, then I will see y'all tomorrow. Love y'all. Let everybody know I miss them too if they were not here for the stream, and if you're here watching it later, that's good too as well. Then you'll hear it there. But I'm going to switch real quick. I'm going to clear this. Yeah, and I will look into TikTok. I will see about if that can help as well, because that would be a good idea. I didn't think about that. Let's see, Control-2, boom. All right, now pre-algebra. Okay, so is there anybody for pre-algebra here? I still haven't. I got 4 people who are watching, but nobody has said anything, so I'm gonna just go over, I guess, some brief topics over algebra or pre-algebra, and if I don't hear for anything, I can just do a quick overview. I'll do 1 or 2 problems. Will be uploaded later, so you can still watch that. So I'm gonna go over slope. So with slope, let's go. Oh, let me change the background so y'all can have a graph. Format background. We're going to do grid. Stick with the gray. We'll start there. We're going to erase. Okay, so with slope, we talked about, so this little triangle symbol right here means delta. That means change. So that's your change in y over your change in x, so how much you go up and down, or how much you go left and right. So if you were to go up, that would be positive, and if you go down, that would be negative. And if you were to go left, that would be negative, and if you were to go right, that would be positive, which should make sense also in terms of physics that y'all are starting right now, and in terms of the number line. Like if you were to look at the number line right now, the more you go to the left after 0, the more negative you are, and the more you go to the right, the more positive you are. And then with terms of up and down, you can think of altitude. So as you go up into the air, your altitude is increasing, so you're getting further and further into the atmosphere. And then, so they use it in terms of sea level. So if you're 20,000 feet in the air, then you're 20,000 feet above sea level, so right above the ocean. And if you're at the beach, then that would be at 0. And then if you were underneath the water, that's when you're going to start having the negative numbers. So with slope, you can do a couple of different things. So if you're given a graph, you have to look for points. Now, this is going to be interesting if I can do this. Let's see how far I can zoom in. Oh, awesome. That was my mistake. Control Z. So this is as far as I can zoom into it. So I'm gonna just try to plot points as best I can for this. So and this is not the best because I messed that one up. So here, and this is going to be my y-axis right there. So I'm going to draw as straight of a line as possible. Let's see if they'll let me. This is my first time using this. How do I adjust this? Well, y'all, I don't know if that's going to work. So we're going to try our best. But if I was to draw a line, as best I can, you can look at 2 points. They go down, and if you were paying attention, I was kind of going down 2 and over 1, or up 2 and over 1. So you would look at points where it would hit the box. I know it's really difficult to see here, so I'll have to come up with something that's a little bit easier to see. But if you had a point right here and a point right here, how would I get from here to here? So you have to think about, like, I have to go up 2, I rise 2, and I have to go over 1. So if I was to write that in terms of our slope, so if I had to go up 2 dots and then over 1, that means we rose 2 over 1. And the big thing about slope is you have to make sure you simplify. So 2 divided by 1 is just going to be 2. If you have something like 1/2, if this had been happening where you go up 1 over 2, so something like this, okay, you would leave it as 1/2. You leave it as a fraction. You can't simplify it anymore. However, I say that with something like 4/8, that can be simplified to 1/2. 4 goes into 4 one time. 8 divided by 4 gives you 2, so it would be the 1/2. So make sure you do simplify your fractions. Now, the other problem is from a table. So if I'm doing it from a table, give me 1 second, y'all. Let me see if I can. Let me see if I can get a set of slope problems that we can just do easy peasy real quick. Pre-algebra. So let's do it from 2 points, like if they gave us the points. So something like a 10 and negative 7, 14. So with this, you can actually do this two ways. So you can use the formula that I gave y'all. So y2 minus y1, which is that shows us our change. That's how that delta, that's what this delta is representing up here. So you're finding the difference between the 2 points over x2 minus x1. So that's our slope. Remember, m means slope. So you can use this formula. That's one way. Now let's say you don't want to remember that. Let's say you've already got to remember so many formulas already. You're nervous about having to remember that. Well, another thing you can do is that since we're just trying to find the difference, you can just put it in a little table ourselves, because this is another way you can do this. And this also helps you with doing the table. So remember, x is on the right or left, and then y is on the right. So our x values, 8 and negative 7. And our y value is 10. Remember, match them up. 8, 10, negative 7, 14. So how did you get from 8 to negative 7? Well, you can do one of two things. And I'm going to change Desmos calculator. If I want to do that real quick. Cool. So the thing you can do is you can put this in, you can do the difference. So 8 minus negative 7, 8 minus negative 7 gives you 15. Or you can think of in terms of a number line. So if we were to go, and you know what, I did that wrong on the calculator for y'all, so ignore that piece. It should have been the inverse. So how did I get from here to here? So how would I'm going down, right? I'm getting more negative. So I have to get to 0 first, right? So I'm at 8, and I want to get to 0. So how far do I have to go down to get to 0? I have to subtract 8. Now I want to get to negative 7, and how do I get there? I have to subtract another 7. So negative 8 minus 7, so that's a change of negative 15. But to get from 10 to 14, that's an increase. That's an increase. You're getting higher. We're getting warmer in temperature, so that's an increase of positive 4. So now, let's just go ahead and put it over change in y over change in x. So what was our change in y? 4. What was our change in x? Negative 15. You will not see it in this form. You won't see the negative on the bottom. So good notation is to either have it directly next to the fraction bar or in the numerator. So either these two answers are correct. You cannot simplify y because this is an even number, this is an odd number, there's not a number that can go into both right now. So we're done. This would be our answer. Now let's say you don't like setting up in the table, you're going to remember this formula, you want to use that. So same thing. We have our numbers, just make sure you keep them the same. So I'm going to use this. So we'll call this x1, y1, x2, y2. Please label. Notice that they're my 2's. These are just little identifiers. They're like little name tags. So hey, they're together. This is a family. This is a family. So this is brother, brother, and then these two are brothers or brothers and sisters or cousins or however you want to remember. But these are together and these are together. So I'm going to rewrite that now. So y2 was 14. Oh, yikes. Let me restart that. Minus 10 over our x2 is negative 7 minus 8. And what happens? So 14 minus 10 is 4 over negative 15. We got the same thing that we did down here. We just need to rewrite it because remember you're not going to have a negative in the denominator. So that makes it negative 4 over 15. And do these match up? Yes, they do. So either way works out for that. Okay, so that's two different ways that you can do this. You can either use the formula, y2 minus y1 over x2 minus, oh, I forgot the x1 right there, minus x1. You may also hear it slightly different where they say y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's just in reference to using this little notation, this subscript. That's what those numbers are. They're subscripts. And like I said, they're just identifiers. You're not squaring anything. You're not doing any type of math to this individual term. You're going to subtract the terms, but you're not going to do anything to that unless just the subtraction. The other thing you can do is to set them up into a table and see how did you get from point A to point B. Did you add 4? Did you take away 15? And then with a graph, if they just give it to you in a graph, again, you can pick 2 points like we did, and either do these two methods or let's see if I can get this to be a little bit easier to see. So I'm gonna kind of do this over here. So let's say they gave us 2 points. I'm gonna try my best to draw a line. It's probably come out pretty awful, so we're gonna just go with the flow for right now. But the big thing is you need to see where they're hitting the corner of the box. So pretending there's a perfectly straight line that connects these points, and as you can tell, that is not perfect. But if it was a perfectly straight line, I already have my 2 points. You can count how to get from point A to point B. So point A to point B, go left to right, just like you were reading a book. So what's my change in y? And what's my change in x? So what is my change in y? How high do I either have to go up or how low do I have to go to the next point? So I can go up 1, 2, 3. So I went up 3. And then how much did I go over? So I went up 3. And then how much did I go over to the right? So I went over 1 to the right. So that's a positive 1. 3 divided by 1 is just 3. That's one way to do it. Now let's say that point wasn't on the paper. It was somewhere else and you couldn't see it. So you would have to go backwards instead. So you could also go the opposite direction. So how far to get from this point to this point? You would go down 1, 2, 3. So that's down 3. So down 3. And you went back 1. So that's a negative 1. So what does that make? A negative 3 divided by negative 1. These are double negatives. So it makes it a positive. So that's a positive 3. Are these the same? Yup. So either way works. Again, so that's 2 different ways you can solve it by a graph. You can either go left to right, right to left. You can set it up in a table. You can use your 2 points and just do the formula. If you're given a large table, instead of just 2 points, you just need to pick 2 of them. It doesn't matter. And you can, again, just find the difference between the 2 or use the formula. Let me see if I can find a table real quick. I'll just come up with one real quick. So, like, if, for example, if you were given a table like, let's do 0, 3, 1, 5, 2, 7, 3, 9. Okay, so again, pick 2 points. You could just pick these first 2, the last 2, the first and the last one. It doesn't matter. And in fact, you know what? Let's go through each one. So to 0 to 1, I increased by 1. From 3 to 5, I increased by 2. So right there, I could write my slope. That'd be 2 over 1. So that'd be 2. I'm going to just scoot this over just a little bit so you can see that. Alright, now let's try... I'm just going to go from each consecutive point, and then we'll do where there's differences in them, and I'll show you that you can still simplify. So from 1 to 2, again, you're just increasing by 1. From 5 to 7, that's by increasing by 2. 7 to 9, increasing by 2. 2 to 3, that's increasing by 1. So again, we're going to get the same slope. 2 divided by 1, 2. 2 divided by 1, 2. Now, let's say you didn't do that. Let's say you wanted to pick your first point and your last point. Well, a different color. So how did I get from 0 all the way to 3, I increased by 3. And then how did I get from 3 all the way to 9? I increased by 6. So then your change in y over your change in x would be different. Well, it looks slightly different, but it'd still simplify the same. So it'd be 6 over 3. And can you simplify that? Yes, you can. You can. How do you simplify that? So what number goes into 6 also goes into 3? Or can you just automatically do 6 divided by 3? Do you know that 3 is a factor of 6? It is. So 6 divided by 3 is 2. And 3 divided by 3 is 1. And what does that simplify to be? 2. So this is the same as this. So it's still, either way, you will still get the same answer. Now, with that though, we then took a step further, not just finding the slope, we then went into slope-intercept. So slope-intercept is a form, it's a linear equation, but it allows us to plot a graph, or for us to give someone a function so they know what the rule is if they wanted to plot it at different points. Because our x's are our inputs and our y's are our outputs, so if we wanted to know the output at a certain point, then we can use slope-intercept form to calculate that. So this is called slope-intercept form, where the slope is our m and the intercept is our b, and that b is more specifically our y-intercept. So where it crosses the y-axis. And our slope is again our change in y over our change in x. You may also see that as rise over run, but it's not just rising, you could also be falling. So that's what our slope is. So for something like 4x minus 3, oh, let's do it positive first. So if we're going to plot that, so you have an m value of 4, that tells us then our change in y over our change in x is up 4 over 1. Why is it over 1? Because 4 is a whole number. It's an integer. And you would always put your integers over 1, because anything divided by 1 is just itself. So we know we're going to go up 4 over 1, and our b is going to be a positive 3, So a lovely sketchy graph. So here's my x-axis, here's my y-axis. So if I was to plot my y-intercept, it would be at a positive 3, so 1, 2, 3. And now my slope. Now, I didn't plan this very well, and I didn't increase as high as I needed to, but we'll still plot it, it's okay. So you can go up 4, because it's a positive 4, so up 4, 1, 2, 3, 4, over 1. So there would be another point. However, you could plot another point without having to go off of this graph that I already did. And how would you do that? You just do the inverse. So if you went the opposite way, down 4, 1, 2, 3, 4, to the left 1, that's going down negative 4, so that's going down 4, so minus 4, and then back 1, that's a negative, so a negative divided by a negative is still a positive. And if you were to connect this, does this still look like a positive slope? Yes, this would still be a positive slope. So that's another thing that you could do as well. Now with though the intercept, you notice that I made this a positive the first way. So if you were to have a different problem, just put this over here. Let's say you had, let's make this even just a little bit more double more challenging. Let's make it a fraction. We'll do 3/4 x, and we'll do minus 2. So if I was to plot that, so I'm going to plot the my y-intercept first, so my slope, right here, 3/4. My y-intercept is going to be -2, so it's going to be -2 for my y value. So I'm going to come all the way down. Here's my origin at 0, 0. I'm going to come down 2 spots, 1, 2. And now for my slope, I can go, since it's a positive slope still, I can go up 3, up 1, 2, 3, and over 4, 1, 2, 3, 4. And then you can go down 3, 1, 2, 3, over 4, 1, 2, 3, 4. And again, if you were to look at that, if you're plotting that, you can see it. Since it's a positive slope, you should see a positive incline, which we do. Now let's say we wanted to instead, this had been a negative slope, so let's rewrite this as -3/4 x plus 2. So our m is a -3/4, and our b is a -2. So you would still have the same y-intercept, you'd still plot that right there, but you would be going down 3, so 1, 2, 3, and instead of going to the left like we did, which would make it a positive slope, we're going to actually go to the right, because it's a going down, it's a negative direction divided by a positive direction, so that stays negative. So we plot here, and then if we wanted to do it the opposite, you can go up 3, 1, 2, 3, and over 4, 1, 2, 3, 4. So notice the difference in these two graphs, just based off the slope. The y-intercept's still the same, but the slopes are different. And I'm gonna try to. Ooh, wow, this is not Control-Z. So I'm trying to use this pen, and it's not. Let's just use my mouse. Nope, even worse. Yeah, y'all, that is not going to work for me working that way. So, but the slope would be going down this way. Alright, if there are any more questions, I can stop it there, and then I'll try to set up the other encoder so maybe we can get not as much delay for tomorrow. I just hope that the questions are still shown up for everybody so they can read them in case they don't show up for the other ones. If there's no other questions, I'm going to stop here. But y'all have a good rest of the day. I miss y'all a lot. I love y'all, and I hope everybody's staying safe and keeping busy. Like I said, just try to make the most of it. You focus on learning something new. It doesn't have to be completely like core related. You can learn a new skill. You could read about something that has been interesting you. If you're bored, you can even make up your own game. I mean, people have been making up their own games on TikTok and all this other crazy stuff that I've been seeing. So keep your mind busy. Don't just be watching a bunch of Netflix and playing video games, which there's nothing wrong with that, but don't be spending all your time doing that. Still keep the brain active and learn something. Anyway, I'm going to sign off. This is going to be uploaded relatively quickly. I'll make some edits if I need to. But I will be on again tomorrow.